2,000 years ago, deep in the Amazon, an entire civilization fed millions of people from soil that should have been useless. They did it with a single substance, a dark powder that costs less than $2 a pound today. One application, no reapplication. And the soil is still fertile, right now, 20 centuries later. That is not a legend. It is a documented, laboratory-confirmed fact. And it raises a question worth sitting with. If something this powerful already exists, why has almost no one at the garden center ever mentioned it? The global fertilizer industry pulls in over $230 billion a year. Add pesticides, pH balancers, nitrogen supplements, and microbial boosters, and the number climbs far higher. Every brightly colored bag on the shelf assumes the same thing, that soil is permanently broken, and the only fix is buying more product, season after season, year after year. But there is another path, a quieter one, a path where a single, inexpensive amendment builds a self-sustaining ecosystem so balanced that it simply does not need to be rebuilt. Heirloom tomatoes, blooming roses, greens so vibrant the neighbors start asking questions, not from chemicals, from biology, set in motion once and left to run. This is the story of biochar, the ancient soil secret that Amazonian tribes perfected thousands of years ago and that modern industry has had very little financial incentive to talk about. The science is real. The results are measurable. And by the end of this, the garden will never look quite the same again. 1. The mystery of the dark earth. Here is something most gardening books never mention. The Amazon rainforest, for all its lush green beauty, sits on some of the worst farming soil on the planet. That sounds wrong. It is worth explaining why it is not. In a tropical rainforest, the nutrient cycle happens almost entirely above ground. Trees hold the wealth. When a leaf falls, surface roots devour it immediately. The actual dirt underneath is thin, acidic, and almost completely stripped of the organic matter that vegetables need to grow. Clear the trees, and what remains is red clay, soil that bakes hard under the sun and washes away with the first heavy rain. Traditional slash-and-burn farming in the Amazon exhausts a plot in 2 or 3 years. Then the farmer moves on, burns another patch, and the cycle repeats. So when the Spanish conquistador Francisco de Orellana pushed his expedition into the Amazon basin in 1542, he expected to find impenetrable wilderness, scattered tribes at best. Instead, he found something that stopped him cold. Massive settlements stretched along the riverbanks for miles. His chroniclers estimated populations in the millions, and surrounding those cities, cultivated farmland, producing abundant food, from the same ground apparently for centuries. How? The answer was literally beneath their feet. Running several feet deep beneath those settlements was a dark, almost black earth, strikingly different from the pale red clay everywhere else. The locals had a name for it, Terra Preta de Indio, the dark earth of the Indians. Dig a hole in untouched jungle soil nearby, and the contrast was stark. Pale, thin, and lifeless on one side, deep, dark, and teeming with life on the other. Same rainfall, same climate, same latitude, completely different soil. For centuries, Western science ignored it. The real investigation did not begin until 1966, when a Dutch soil scientist named Wim Sombroek published a landmark book called Amazon Soils. When modern researchers finally analyzed samples of Terra Preta, the microbial activity readings broke their standard scales. But here is the detail that sent shockwaves through the scientific community. Left completely alone, Terra Preta spreads. It converts the depleted soil around it into its own rich, dark likeness, slowly, steadily, without any human intervention. Researchers initially assumed the fertility came from standard organic matter, composted waste, fish bones, manure. Logical enough. But carbon dating told a different story. The carbon in Terra Preta was thousands of years old, and it was not decomposing. Normal organic carbon breaks down. This was not normal organic carbon. It was char. What the scientific world now calls biochar. Those ancient Amazonian civilizations had not simply composted their waste. They had systematically created charcoal under controlled conditions and worked it into their land. They built a soil architecture so permanent that more than 2,000 years after their civilizations collapsed, the dark earth remained, as fertile as the day it was made. And that raises a much bigger question. If biochar can do all of this, what exactly is happening at the microscopic level, and why does it last so long? 2. The science behind the powder. Most people have burned wood in a campfire. Full combustion turns wood into carbon dioxide and water vapor. The carbon floats away as smoke, and what is left is a pile of powdery ash. Useful for almost nothing in the garden. But change one variable, and the result is completely different. Heat organic material, wood, plant stalks, even nutshells, at temperatures between 300 and 700 degrees Celsius, but restrict the oxygen supply so it cannot fully combust. This process is called pyrolysis. The volatile gases escape. The cellular structure breaks down, but the carbon skeleton, the rigid microscopic framework of the original material, stays intact. What remains is not ash, it is a lattice of pure carbon, with a structure so intricate that a single gram of high-quality biochar contains between 200 and 400 square meters of internal surface area. To put that in perspective, the surface area of roughly 4 tennis courts, compressed into a crumb small enough to pinch between 2 fingers. That number matters. Here is why. Soil fertility is not really about dirt. It is about the microorganisms living in the dirt. Bacteria, fungi, archaea. The invisible workforce that makes nutrients available to plant roots. These organisms are tiny. The microscopic spaces between soil particles are their entire world, and they do not like being exposed. A heavy rain flushes them away. Direct sunlight kills them. They thrive when they can colonize protected surfaces and build stable communities. Biochar gives them exactly that. Each particle is riddled with millions of microscopic caves, tunnels, and chambers. Fungal networks thread through them. Beneficial bacteria coat the interior walls. Organisms that would normally wash straight through sandy soil finally have a permanent address. The population density of microbes around a single biochar particle can be orders of magnitude higher than in the untreated soil just a fraction of an inch away. That is not a small difference. That is a different ecosystem entirely. And here is the distinction that changes everything about how to think about soil health. Biochar does not feed the soil. It houses the organisms that feed the soil. That single sentence is worth reading twice because it overturns the basic assumption behind every fertilizer purchase ever made. Feeding is temporary. Every bag of synthetic nitrogen fertilizer delivers a quick spike, fast food for plants, followed by an inevitable crash. The soil itself stays hungry. The microbial population spikes briefly and then collapses when the synthetic input runs out. It is a boom and bust cycle that mirrors what happens to farmland under monoculture. Short-term gain, long-term depletion. Housing is permanent. Once the microbial community moves in and stabilizes inside biochar's pore network, something remarkable begins. Mycorrhizal fungi, thread-like organisms that extend plant root systems by orders of magnitude, weave through the tunnels and reach mineral deposits that roots alone could never access. They pull phosphorus from locked-up soil particles and deliver it directly to the plant in exchange for sugars. Meanwhile, nitrogen-fixing bacteria settle into adjacent pores and begin pulling nitrogen straight out of the atmosphere, converting it into a form plant roots can absorb. Free of charge, no bag required. This is exactly why Terra Preta appears to spread on its own. The thriving microbial ecosystem it supports slowly heals and transforms the exhausted soil around it, year after year, with zero additional input. So the science is clear. But if this is real, and it is, then an uncomfortable question follows. Why is this not common knowledge? Why is there no biochar aisle at the hardware store? Three, why almost no one talks about this. The synthetic fertilizer industry is not small. The major manufacturers represented by the Fertilizer Institute have combined revenues exceeding $80 billion annually. Add pesticides and herbicides, and the figure climbs sharply. The entire business model rests on a single assumption. Soil is essentially a dead container. Pour in synthetic nitrogen, phosphorus, and potassium. Extract the harvest. The soil depletes. Buy more product next spring. Repeat forever. If the soil becomes compacted or acidic from years of chemical application, there is another product for that, and another for the problem that product creates. The cycle is self-reinforcing and extremely profitable. Biochar disrupts that cycle at the root, not because it replaces fertilizer with another product, but because it gradually eliminates the need for external inputs altogether. A landmark long-term study published in 2009 tracked biochar-amended soils over 12 years. By the end of the observation period, those soils required 45% less external fertilizer. By year 15, the need for synthetic applications had effectively disappeared. From a business perspective, that is not a product any fertilizer company would rush to promote. A one-time purchase that steadily reduces the customer's dependence is the opposite of a recurring revenue model. This is not a dramatic conspiracy. No one held secret meetings to suppress biochar. It is simpler and more structural than that. Research funding flows toward technologies that generate ongoing sales, not technologies that make customers self-sufficient. Gardening media runs on advertising from chemical companies. The financial architecture of the industry simply does not reward talking about biochar. But the research exists regardless, and the numbers are striking. A recent meta-analysis of 438 global studies, including long-term field experiments across multiple continents, found that sustained biochar application increases global crop yields by an average of 10.8%. It raises soil organic carbon content by 52.5%. And when combined with standard fertilizers, biochar boosts crop yield by up to 48% compared to unfertilized land. Larger tomatoes, brighter flowers, healthier root systems, all with less money spent and less physical labor hauling bags from the store every spring. But yield and savings are only part of the picture. There is something biochar does for health and for the environment that makes the story even more compelling. 4. A shield for health and climate. Every year, agriculture generates enormous volumes of crop waste. When that waste is burned in the open or left to decompose, it releases methane and nitrous oxide, two greenhouse gases far more potent than carbon dioxide. Nitrous oxide, in particular, traps roughly 300 times more heat per molecule. Converting that same waste into biochar through pyrolysis flips the equation. Studies show biochar reduces methane emissions from soil by 13.5% and cuts nitrous oxide emissions by 21.4%. Instead of carbon cycling back into the atmosphere, biochar locks it underground, stable, inert, and sequestered for centuries. A permanent carbon sink, built one garden bed at a time. But here is the benefit that matters most to anyone growing food for their family. Decades of industrial activity have left heavy metals, lead, cadmium, zinc, scattered through soils across the country. These contaminants can silently migrate into the root systems of vegetables. The produce looks healthy. It tastes fine. But the metals are there. Biochar's vast internal surface area acts as a filter. Its porous structure and unique surface chemistry bind heavy metals and immobilize them, locking contaminants away so they cannot reach plant roots. Adding biochar to a garden bed is, in a very real sense, purifying the ground before the first seed goes in. For anyone who has spent years building a vegetable garden near an old house, a busy road, or in a suburb built on former industrial land, this is not a small thing. It is the difference between hoping the soil is clean and actually making it clean. It also buffers soil pH naturally. Acidic soil, the kind that turns hydrangeas blue and makes tomatoes struggle, gets gently neutralized. Anyone who has spread bags of agricultural lime every spring knows the routine. Test, apply, wait, test again, reapply. The correction never holds. Biochar does the same work, but durably. The alkaline minerals bound within its carbon structure release slowly, keeping the pH in a stable, plant-friendly range for years rather than months. One application handles what lime needs to be reapplied to manage every single season. So the question that naturally follows is the practical one. If biochar does all of this, how does it actually get from concept to garden bed? And what is the one mistake that trips up nearly every beginner? 5. From the Amazon to the backyard. Walk into a typical garden center and ask for biochar. The response, more often than not, will be a blank stare. The few stores that carry it tend to stock small, brightly packaged bags priced at $25 to $35. That markup is enormous. Bought in bulk, from agricultural suppliers or online, the same material runs about $2 a pound. The retail packaging is designed to make it feel rare and premium. It is neither. Better yet, biochar can be made at home from organic waste that is already lying around the yard. No laboratory required. The simplest approach is the cone pit method. Dig a shallow, cone-shaped hole, build a hot fire inside with dry wood and twigs, and once a strong bed of coals forms, begin feeding in dry biomass, wood scraps, plant stalks, nutshells. The goal is controlled charring, not full combustion. Restrict the oxygen just enough that the material blackens and smokes without bursting into open flame. When the pieces are thoroughly charred, black, light, and no longer producing volatile smoke, quench everything with water to lock the carbon structure in place. A clean metal 5-gallon bucket with a tight-fitting lid works too. Fill it with dry biomass, set it in the center of a campfire or fire pit, and let the heat do the work. The lid restricts oxygen inside the bucket while the surrounding fire provides the temperature. After cooling, the result is clean, usable biochar. Now, here is the single most important thing to know before putting any of this in the garden. This is the step that trips up almost everyone the first time. Raw biochar should never go directly into the soil. Remember those millions of empty microscopic pores? Freshly made biochar is bone dry and completely vacant. Placed into a garden bed in that state, it acts like an aggressive sponge, pulling nitrogen and moisture away from plant roots. The garden will look worse, not better, for weeks. Many people try biochar once, skip this step, see their plants suffer, and conclude the whole thing does not work. It does work. They just skipped the charging. Charging biochar is simple and ancient. Mix the raw char into a pile of finished compost, aged manure, or soak it in a batch of actively brewing compost tea. Leave it there for 2 to 4 weeks. During that time, microorganisms and dissolved nutrients flood into the pores, colonizing every internal surface. The biochar goes from empty housing to a fully occupied microbial neighborhood. When charged biochar finally enters the garden, it arrives already alive, supporting the soil ecosystem from day one instead of competing with it. For established garden beds, work about 2 to 4 pounds of charged biochar per square foot into the top 12 inches of soil. For containers, porch pots, raised planters, patio gardens, mixing 15 to 20% biochar by volume into the potting mix delivers strong results. The first season or two may feel slow. That is normal, and it is worth understanding why so that impatience does not undo the investment. The microbial community is building. Root networks are expanding into the newly available pore spaces. Nutrient cycling is ramping up, but has not yet hit full capacity. Some gardeners report modest improvements in year 1, and then dramatically better results by year 2 or 3. Healthier foliage, stronger root systems, better water retention during dry spells, and visibly richer soil color. The trajectory is upward, and it does not reverse. Once established, it is permanent infrastructure, not a treatment that fades, not an amendment that washes away. A one-time installation that only improves with age, as successive seasons add more organic matter, more microbial diversity, and more nutrient cycling capacity to the system already in place.
And that permanence, that idea of building something once and having it outlast everything else, turns out to be the most remarkable part of this entire story.
6. A legacy written in the ground. The civilizations that built Terra Preta are gone. Their cities vanished under jungle canopy. Their languages, their art, their daily lives dissolved into history. But the soil they prepared is still there, still dark, still fertile, still spreading. They did not survive because they built monuments. They survived, in the most literal, measurable way, because they changed the chemistry of the ground beneath their feet. Everything else they created has disappeared. The soil remains. Every handful of charged biochar worked into a garden bed is a small echo of that same idea. It captures carbon. It filters contaminants. It reduces dependence on an industry built on planned obsolescence. And it leaves behind a patch of earth that will still be producing life long after the person who amended it has moved on. A grandchild digging in that soil 20 years from now will find it darker, richer, and more alive than the ground next door, and may never know why, unless someone tells them the story. The powder costs $2. The results last for centuries. And the only reason more people do not know about it is that no one profits from selling a product just once. That is worth changing, one garden at a time. That is the story of biochar, from a lost Amazonian civilization to the backyard garden bed. Ancient knowledge, modern science, and a $2 bag of charred carbon that quietly outperforms products costing 10 times as much. The tribes who invented it are gone, but the soil they built outlasted their temples, their tools, and their spoken words. That alone should tell us something about where real permanence comes from. If something in this struck a chord, drop a comment below. Share what has worked in your garden, what has not, and what you are curious to try next. Every experience shared here helps someone else grow. Hit the like button if this was useful. Share it with a friend who loves their garden, and subscribe to Rooted Grace, because there is always more to uncover, and the best conversations happen when this community keeps growing. Until next time, keep your hands in the dirt and your mind wide open.